Okay, we want to graph these two equations and estimate the coordinates of the crossing point. Crossing point will be XY point. The values will have coordinates that are the X and Y coordinates, or X and Y values that make both equations true. All right, so how do we graph the equation? Let's just review that real quickly. In the form you have these equations, your first choice ought to be to graph by finding the intercepts, because that's probably the easiest way to find 2 points. You can always solve the equation for y and get the slope and the y-intercept, and that's perfectly okay too. But this is a little quicker and more direct. Of course, you have to remember what the intercepts are. The intercepts are the points on the y-axis and the x-axis to satisfy the equation. Okay? So on the y-axis, well, the x-coordinate is always 0. So the y-intercept occurs when x equals 0. So we let x equals 0, plug that into the equation. We get 4 times 0 plus 2y equals 8, and that's a very easy equation. And we have no problem solving that. We get y equals 4, meaning that the point 0, 4 is on the graph. It's on the y-axis, so it's the y-intercept. The x-intercept occurs when y equals 0. Now, this is an important point because students in an integrated algebra course do tend to lose track of what the x and y intercepts are. Okay, now, the way we define it is the x-intercept is the point where y equals 0. And the y-intercept is the point where x equals 0. It's best if we understand the reasoning behind that, but that leads us directly to a picture like this. Okay, so I can draw a straight line, more or less straight, through these points. And then I can draw a straight line through these points doing the same thing. Since we haven't completed this problem, I'm going to change the number on the right, because with a 2 on the right, our x and y intercepts are pretty small. It's hard to graph the equation when the x and y intercepts are pretty small. I was going to solve this equation for y and do a slope intercept. Let's stick with finding the intercepts. Let me change the number over. Okay, now that's probably off the screen. Let's make sure we can see it. Okay, so I don't want to have a 2 there anymore. I want a different number. So let's try. I'm not getting anywhere. Like, just go with 6x minus 2y equals 30. Okay. That's a little big. Let's go. Okay, so if we do 6x minus 2y equals 30, and we let x equal 0, we get negative 2y equals 30, so y would be negative 15. If we let y equal 0, then you're going to get 6x equals 30, so x would be 5. So I have to extend this graph a little bit. If this is 4, 8, 12, 16, negative 15 would be about here. Okay, well, we can do this. This would be 0, negative 15. And then the x-intercept would be 5, 0. And I'm not going to work that out because you can easily do that. Do the same thing I did here. Let x equals 0, you get the y-intercept. Let y equals 0, you get the x-intercept. Just have to remember to do that. That's probably the easiest way to get a good straight line. Well, this is 2, here's 4, and here's 5. Let's just say that this is 5, 0. And then I draw a straight line through these points. Okay. So here's where x equals 2. Here's where x equals 5. Here's where y equals 4. I don't have y equals 4. Come down to equal distance, we get y equals -4. Now what we want to do is estimate the coordinates of this point. So here's the problem point. Now what's the x coordinate here? Well, here x is 2, here x is 5. And if you want to put a scale on it, you could do 1, 2, 3, 4, 5. That'd be okay. There's a vertical line through the point. And here's a horizontal line through the point. Now, what do you think the x and y values are? Kind of once again, we find the x and the y intercepts of this equation, and then we do the same thing for the second equation, and we sketch x and y intercepts of first equation here, and the second equation here. We draw the line through the graph. And then we label. This is a line 4x plus 2y equals 8, and this is a line 6x minus 2y equals 30. We have the crossing point. We want to estimate the x and y coordinates. Well, this line goes through the x-axis pretty close to x equals 4. And the y-axis, well, if this is y equals -4, it's probably about y equals -6. So I say, okay, this line is probably somewhere around x equals 4. And this is around y equals -6. So that the crossing point would be 4, -6. Now we can check this. If x equals 4 and y equals -6, 4 times 4 is 16. 2y would be 2 times -6 would be -12. And we get 4 on this side, we get 8 on this side. Now that's not correct. So we don't have a really good estimate here. But it's not too far wrong, especially considering the way we sketched the graph. I would say x is, well, let's do this. Okay, so now if x is 4, 6x would be 24. And then 2 times -2 times -6 is -12. We get 36 instead of 30. So the coordinates of the point don't give us really good results, but we're probably not too far off. Now, what we want to do is look at the algebra. Okay, now let's make sure we understand this process. Again, it comes down to we graph these two lines. So we have to know how to graph equations of two lines. We can use intercepts, or we can solve for y and use slope and intercept. That depends on which one is easy. Okay. Well, now we're going to do this for algebra. We got 4x plus 2y equals 8, and 6x minus 2y equals 30. If we add the two sides of the equation, we get 10x here, 2y, negative 2y is 0. 8 and 30 is 38. And we easily solve this. We'll use decimals this time. X equals 3.8. Okay. Now that's easy. And everybody in here actually kind of wanted to start this, or at least a lot of people did, wanted to start with the equation and solve that the 2y and the negative 2y add up to 0. I don't like putting lines through it, but if you do it right, I'll tolerate it. Again, people misuse cancellation. So I want to make sure we understand why we get a 0 here and why the solution of this equation is x equals 3.8. If we take this 3.8 and plug it into the first equation, yeah, 4, it's 4x, but that means we're going to want to do 4 times 3.8. Then that's plus 2y equals 8. Now we just do the arithmetic. We multiply this out. I believe this gives us 15.2 plus 2y equals 8. Then we subtract 15.2 from both sides. And we get this. And 15.2 minus 15.2 is 0, so we get 2y. 8 minus 15.2 is negative 7.2. So that 2y divided by 2 equals negative 7.2 divided by 2. And that gives us y equals negative 3.6. So you see, on our graph, and I don't know how we ended up being that far off, but we sure did. See if we can go down. Okay, anyhow, the best value of x is 3.8. Well, we estimated 4 for the crossing point. It's actually 3.8. Our estimate of negative 6 appears to be really pretty far off. Y should be negative 3.6. So it's like it crosses here, and somehow can't resolve that. My picture isn't great, but it's not that far off. But apparently it is. Okay. Anyhow, this solution doesn't agree great with this picture, but it doesn't agree that bad. We can check. So let's check our solution. I'm going to plug those values into the second equation, not the first, because the first equation is what we used with the 3.8 to get this. So it's possible that we made an error in getting x equals 3.8, but if I solve this correctly, negative 3.6 is going to be correct for this equation. 3.8, 3.6 will be a solution to this equation. We want to see if it's a solution to this equation, because this value depends on the second equation as well as the first. Okay, so we get 6 times 3.8 minus 2 times negative 3.6 should equal 30. In other words, this is the second equation where we replaced x and y by these two numbers. Now 6 times 3.8 is 21 point, it's all 22.4. done that correctly, I think I have. I get 22.4 plus 7.2 equals 30. Now, 22.4 plus 7.2 is 29.6. So something is haywire in my solution. And I don't see what it might be. Did I multiply 4 by 3.8 correctly? That would be 12, and 3.2 is 15.2. 8 minus 15.2 is negative 7.2. I don't see the error. I know there is one because this didn't quite work out. And my arithmetic here, I just kind of double checked it. I did it in my head, so there's something wrong with my head apparently. And it fell on my head. Okay, so it was my arithmetic here. I didn't do it quite correctly. It should be 22.8. I want to be careful if the arithmetic is correct. But when I get that, I get 30 equals 30. So it did check out, but I messed up my arithmetic in the check. If I mess up one step in this whole thing, I'm not going to get the same numbers now. Okay. So this is a confirmation that I solved the equation correctly. So there's actually more than one way of solving the equation. You've seen solving by graphing, and this is called solving by elimination. We eliminated y from the two equations. Okay, that's actually the technique that's more important for linear equations. Okay, so when we have linear equations, we're usually going to write them like this. If it's not a linear equation, we have to use substitution, and we'll see that also. Okay, well, let's go ahead and do another example. Let me ask you to now we're not going to take any more time on graphing, but we do want to review that and get that down. Okay, make sure that you can graph these. And I recommend that when you solve these, you do it by graphing and you follow the procedure, find the intercepts, sketch the graph, estimate your solution. Okay. Okay, let's take another equation. Let's take 5x minus 3y equals 4. Go with 1. Okay. And 4x plus 3y equals 10. And no, I want that to be 13. Can you follow these steps like we did? Well, you're going to add these two equations, and then you're going to go on, right? Okay, let's see what you do. I apologize, I intended this to be easy to solve, and it is if you put 17 there. If you put 13 there, you're going to get fractions, and you can certainly do that. You should be able to, but for an introductory problem, we're going to do it with 17. So please, if you're a distance student, pause and work this out. Okay, well, hopefully you paused and solved this equation. So what we get if we add these two equations is we get 9x, adding the x's, plus 0. And if we add negative 3y and 3y, we get 0. That equals 18. And of course, that becomes 9x equals 18. Divide both sides by 9. and get x equals 2. Take the x equals 2 and we plug it in. Use colors here. And we take it out. We plug it in here, which gives us the equation 5x. I'm going to write the rest of the equation down before putting in x, just because I got to switch hands here. Okay. X is 2, so 5x is going to be 5 times 2. We get 5 times 2 minus 3y equals 1. And we end up with y equals 3. Let me check. If you haven't done the check, do it before you see me do it. Okay, we're going to plug into 3y. Into the second equation. Because we plug it into the first equation, all we do is we confirm that these steps are correct. It doesn't confirm that the step where we added the 2 equations is correct. If we plug it into the second equation, then we're also testing whether we added the 2 equations correctly. Okay. Another way of saying it is, if we made a mistake in adding the 2 equations together, we wouldn't detect the mistake by plugging y equals 3 into the first equation. Okay. Because we plugged the x equals 2 into the first equation. We got y equals. Okay. Well, I don't want to say too much more about that. It's a bit of a subtle point. But we want to plug into the equation that we didn't use when we substituted the x equals 2. So what we get now is 4 times 2, or 3 times 3. We get it's minus. Okay. Minus 3 times 3 is 1. Well, 4 times 2 is 8. 3 times 3 is 9. And 8 minus 9 equals -1. And we put a big old check mark next to that. All right. Well, that is simple enough. But it's not that simple. So that's a process that we want to practice. Now I want to solve a system that's a little trickier to solve. It's going to be here it is. Now, we might not see what to do with this. So pay careful attention to my notation. I'm going to use 1 here with a circle, and I'm going to use 2 here with a circle to indicate equation 1 and equation 2. These are not numbers that go into the equation. They're separate from the equation. But it allows us to number the equations, okay? And I'm going to put a kind of wavy line here. I'm not going to put a straight line. I'd use a straight line if I was going to add the equations, okay? Whereas in this equation, we have a minus 3y and a plus 3y, so it's obvious that we could eliminate y. Because what we did was eliminated y and found x and so forth. We don't have numbers that are equal and opposite up here. So what are we going to do? We're going to double the first equation. So by double, I mean we multiply both sides by 2. And that means we multiply every term by 2. If we double 3x, we get 6x, double 6x, we get 6y, we get 12y, double 15, we get 30. And then we write down the second equation. Negative 6x plus 5y equals 4. Okay. Okay, well now, this is the first equation and this is the second equation. What are we going to do here? Well, now we can proceed just as we did over here. We can add the x's and then it's going to eliminate x. So we get 0 plus 17y equals 34. In other words, just 17y equals 34. And you divide both sides by 17. We have to assume everybody knows to do that. And we get y equals 2. And then we take y equals 2. Plug it into the first equation. And bring a big old looping arrow down here. That gives us the equation. 3x plus 6y, and y is 2. That's equal to 15. We solve this equation. Find out and do the solution, and we get x equals 1. Now we plug x equals 1 into the second equation. And the equation that we get is going to be negative 6 times 1 we're going to plug the numbers, both the numbers. We're going to plug x equals 1, y equals 2. Into our second original equation. So this is going to plug into the second equation here, not the second equation here. And we're going to get the negative 6 times 1 plus 5 times 2 equals 4. If we do the arithmetic, we get 4 equals 4. And it checks. Now, just to be sure that we see the geometric picture here. X and y intercepts from this equation are 5, 0, and 0, 2.5. So I can graph that. Put the 5, 0 here. And 0, 2.5 here. And sketch a line that kind of misses both points by about the same amount. Get the idea. Okay. Now to solve. All this, your intercepts, your x-intercept is going to be negative 2/3, and your y-intercept is going to be 4/5. That's how your y-intercept will be negative 2/3. All right, your x-intercept is negative 2/3. Your y-intercept is 4/5. Negative 2/3 would be down here. Over here. And negative 2/3 would be here, and your 4/5 would be about here. Those points would be very close to the origin. It's going to be hard to get the right angle if we use the intercepts. They're too small. Okay, it's hard to see just exactly where the straight line would have to be. I'm going to use the y-intercept and the slope. Solve this for y. We have 6x to both sides. Get rid of x from this side. That leaves us 5y equals 4 plus 6x. And we divide by 5. We get y equals 6/5 x plus 4/5. Now we know the slope is 6/5 and the y-intercept is 4/5. Now where's 4/5? This is 2.5, then 1 is about here. Then y equals 4/5 would be about here. And we would use the slope, which is 6/5. Well, slope is 6/5, which is like 1.2. That means if we're to count over 6, you'd have to go up 5, which is about here, which would be the graph, something like this. I don't want to go into the detail of that, because it's kind of a distraction. Here's our crossing. So once we've graphed these two equations, we get a crossing point that looks to be, this is 5, this could well be 2. If this is 2.5, then this could be y equals 2. So that our crossing point would be where x equals 1 and y equals 2. Sorry, x equals 2. Okay, that means x would be 2, y would be 2. If this graph was accurate and that estimate was good, x equals 2, y equals 2 would be a solution. What we got was x equals 1 and y equals 2. That's not too far off. If we did a better job on the graph, maybe this thing a little steeper, maybe, although probably shouldn't be. We come out with a better estimate. So just illustrating the fact, if we graph the two equations and do an estimate, then we can use that to confirm what our algebra will tell us. Let's look at one more equation. We can do some elimination. Let's do 3x plus 2y equals 9. I'm not going to actually solve this. And then let's do 4x plus 5y equals 12. In order to eliminate either x or y, we're going to have to multiply both equations by different number, each equation by a different number. So here's equation 1, here's equation 2. Got that, okay. I'll just illustrate what we do. What do you want to eliminate? X or Y? Point this way for X, point that way for Y, doesn't matter. Point your finger in one direction or another. Okay, so we're going to eliminate X. Okay, so what we're going to do is we're going to multiply this equation by 4, and we're going to multiply this equation by 3. That'll match up the X coordinates. I just multiply this equation by this number, this equation by this number. Except then I make one of them negative. You see how that works. So the first equation, multiply this first equation by 4, I'm going to get 12x plus 8y equals 36. Second equation, I'm going to multiply by negative 3. And I'm going to get negative 12x minus 15y equals negative 36. Oh, that was an interesting combination. Okay. I wrote down those numbers kind of randomly. It turns out that the numbers here are going to give me 0. Anyhow, okay. Do we understand why I did that? Well, it's because 4 times 3 is 12. That's how we got this. 4 times the first equation, we'd have 4 times the 3x. And 3 times 4 is 12. So 3 times 4x would be 12x. But I want it to be negative, so I use negative 3 times the second equation. That's going to give me 0 minus 7y equals 0. Well, that can happen. We get negative 7y equals 0. So we get y equals 0. Well, we can plug that into one of the equations and get an x coordinate and so forth. Rest of the solution after we've done this and eliminated one of the variables is just the same as everything we've done already. So we can just pick the variable we want to solve for and multiply one equation by the number from the other equation. So along the way we did this. Now really we want to do this using the least common multiple of 2 numbers. But for right now, I'm going to leave it at, it'll always work if you just use the 2 numbers. If I multiply this equation by 5 and this equation by negative 2, my y's would match up. And I'd eliminate y. If we're going to solve the first, okay, I'm going to illustrate substitution just with a set of linear equations. Usually we won't use substitution with linear equations because they can be solved more efficiently by elimination. But if the equation isn't linear, and we'll see what that means for too long, we really don't have usually a good method for solving other than substitution. Okay, so same system of equations we had here. We solve for y. Solve the first equation for y. So well, we get y equals 9/2 minus 3/2 x. We just subtract 3x from both sides, divide both sides by 2. Very easy to solve this for y. Now, just as we did when we had a numerical solution, I can take this and plug the solution into the second equation. So I take this solution and plug it in for y here, and that gives me the equation 4x plus 5 multiplied by that solution equals 12. That'd be 5y here, but we're going to write down the 9/2 minus 3/2 x. Okay. Then we use the distributive law. 5 times 9/2 is 45/2. 5 times negative 3/2 is minus 15/2. And then, since we have denominators, we multiply both sides by 2. That gives us 8x plus 45 minus 15x equals 24. Well, by rearranging that gives us negative 7x equals negative 21. So after doing a couple of steps, we get x equals 3. Okay. So this is different than what we did here. This won't work if we have like an x squared or square root of x or, a reciprocal of y or something like that. It only works if we have linear equations. This method would work. Now we could easily get an equation that we can't solve, but it would work if we can solve the equations. For this method. And the idea simply is solve one of the equations for x or for y, and then plug that into the other equation and see what you get. I don't have time to do any more with it. And it'd be good if we could work out the details of an example. But with this introduction, I think the Open Math videos, the text, all the support you get through Open Math if you're a distance student, or if you're a student sitting in a seated section, should allow you to work out the method of substitution. Of course, probably talk about that a little bit more next time after you've had the opportunity to do the homework.